Hi, I'm Max Kirkin, and today I'm going to be teaching you how to find probabilities using the standard normal table. Look at this example problem.
In this problem, we are told that it is normally distributed and we are given the mean and the standard deviation.
It's trying to ask us to find the probability that x is less than 2. So first we have to find z-score. To find z-score, the formula is z equals x minus mu over sigma. And we just plug all these numbers in and it comes out to z equals negative 0.8. And then we always write 0 because we're always going to the 100th place when you're doing z-score. So z equals negative 0.80. So then we go to our standard normal table and we go negative 0.8. And we look on the top, negative 0.80. So we find where they cross paths here. So probability that x is less than 2 equals 0.2119. And that's it for this. Same problem, we have the same mu equals 2.4, the same standard deviation equals 0.5, but now let's say we're trying to find the probability that x will be greater than 3. So this one's a little bit trickier. So what we're going to do is we're going to draw. And now we're going to have the 2.4 as the mean again, which should be approximately halfway through that you're drawing. And we're trying to find x is greater than 3. So we have 3 and then greater than 3. 3 and everything greater than that is what works for our problem. So we have z equals x minus mu over sigma. And this z comes out to 1.2. And we always write 1.20. 1.20. So z equals 1.20. And now when we find 1.20 on the standard normal table, which should be right 1.20, that's saying the probability that x is less than 3 is 0.8849. So what we're going to do is we're going to do 1 minus 0.8849, and this comes out to 0.1151. So now we know that the probability that x is greater than 3 is equal to only 0.1151. That's it. Okay. Now they may ask, find the probability that x is less than 2.5, but x is greater than 2. So what we have to do for this, it's a two-step problem. So we draw an x, we still have the mean is 2.4, and we want to find that x is less than 2.5, but it's greater than 2. So we have shaded in between here. So we have our mu as 2.4, our standard deviation is 0.5, and our 2 is less than x, which is less than 2.5. And now let's first find the probability that x is less than 2.5. So we write z equals x minus mu over sigma, and then 0.20 we write as a z-score. So we go to our standard normal table, look for 0.20, and it's 0.5793. So we have the probability that x is less than 2.5 is equal to 0.5793, 0.5793. So we have this. Now we have to find the probability that x is less than 2. And we know we found in the previous problem that the probability that x is less than 2 is equal to 0.2119. So now we subtract the probability of x less than 2.5 minus the probability x less than 2 equals, and we have 0.5793 minus 0.2119 equals 0.3674. So now we have the probability that 2 is less than x is less than 2.5 equals 0.3674. That's it, guys. Thanks for watching. Now I hope you learned how to find probability using the standard normal table.